You know, every single time you click your mouse, drag a file, or type on your keyboard, your computer is watching. It's basically keeping a secret diary of everything you do. And today, we're going to learn how to read it.
All right, let's just jump right in with a question I'm sure you've wondered about. You drag a file to the recycle bin, you click empty, and poof, it's gone, right? It just vanishes into thin air. But is it really?
Well, the short answer is not even close. In the world of digital forensics, you have to work from one basic truth. Your computer has a nearly perfect memory. It remembers way more than you think, and it almost never truly forgets anything. And the proof of this memory is scattered everywhere in what investigators call digital artifacts. The best way to think of them is as digital breadcrumbs or fingerprints. Every single time you use your computer, you're leaving these little traces, hidden files, logs, all sorts of things, and every single one tells a story. So to understand how to read that story, we've got to start with one of the most basic and, believe it or not, one of the trickiest concepts out there: time. Because on a computer, time isn't as simple as just looking at the clock on the wall. You see, your computer is always juggling at least two different clocks. You've got local time. That's what you see on your screen, 2 p.m. in Chicago or whatever. But for an investigator, the real truth, the gold standard, is universal time, or GMT. It's a single global time that lets an analyst in Germany accurately figure out what happened on a computer in Brazil. It wasn't always this slick, though. Older computer systems just stored the local time, which was simple for you, the user, but it was a total nightmare for global investigations. Now, modern systems, like the kind Windows uses, are way smarter. They record everything in that universal GMT, and then they just do a little math to show you your local time. It's a bit more complex under the hood, but for an investigation, it's so much more accurate. And when I say precise, I mean you have no idea how precise. So let's decode what one of these timestamps actually looks like to a forensic investigator. Yeah, forget about hands on a clock. To a forensic analyst, time looks like this: a big jumble of code. This is a Windows 64-bit timestamp, and it's hiding two absolutely mind-blowing secrets. First, it's precision. This thing doesn't just track seconds or even milliseconds. It tracks time in 100 nanosecond intervals. That is a 10 millionth of a second. It's a level of detail that lets you pinpoint an action with almost unbelievable certainty. And if that wasn't wild enough, the second secret is just its sheer scale. This system is so big it can track every single one of those tiny little intervals for over 58,000 years. I guess Microsoft was really planning for the long haul when they designed this thing. Okay, so we've got the when down to a 10 millionth of a second. That's pretty solid. Now let's get back to our original question and find out what really happens to the what and where when you delete a file. See, when you send a file to the recycle bin, it's not actually deleted. It just goes on a little journey. First, the computer marks its original location as available. Then, the file itself gets moved and gets a new cryptic name. And finally, a super detailed entry about this whole trip gets made in a secret logbook. Let's look at that first step. What you're seeing here is how a forensic tool views that original folder. The entry for our file is now marked deleted, overwritten. The system now knows that space can be used for something else, but the record, the ghost of what was there, still exists. So where'd it go? Well, here it is, in its new home, the recycled folder. But notice, it's not called by its original name anymore. Now it's something like DD4. This name isn't random. It's a code that tells an investigator it was deleted from the D drive and it was the fourth file to be indexed. So how on earth does the computer remember that DD4 used to be your important document? Ah, that's the job of the Info2 file. This is that secret logbook we were talking about. It's a hidden little database that carefully connects the file's new cryptic name to everything about its old self. Its original name, its original location, and, using that super precise timestamp, the exact moment it was deleted. And get this, even trying to cover your tracks by restoring a file leaves a clue. When you restore something from the recycle bin, the entry in that logbook isn't erased. Nope. The system just changes the very first letter of the record to a special code that basically tells the computer, hey, ignore this, pretend it's not here. But for an investigator, that invisible record is still there, and it's perfectly readable. So we know what was deleted, we know where it came from, and we know exactly when it happened. But this all leads to the biggest question, the most important one: who did it? This is where we find the digital fingerprint.
Just think about it for a second. On a shared computer at home or in an office, anybody could have deleted that file. So how can an examiner say with certainty that it was one specific person and not another?
The answer is hiding in plain sight. When an investigator looks inside the recycle bin directory, they don't just see files. They see these folders. And those names, which just look like a bunch of random numbers, are actually some of the most important clues on the entire computer. Each of those long numbers is a security ID, or a SID. This is it. This is your unique digital fingerprint on that machine. Every single user account has one, and it can't be changed. When you delete a file, Windows creates a folder named with your specific SID and puts the deleted file right inside it. It's a direct, undeniable link between the action and the user. And just like that, all of the pieces of the puzzle just snap right into place. The entire evidence trail is now complete.
An investigator can now draw a straight, unbroken line connecting a specific user, thanks to their SID fingerprint, to the exact file they deleted, thanks to the NFO2 logbook, all happening at the exact moment in time, proven by that crazy precise 100 nanosecond timestamp. You know, the people who wrote one of the main forensic manuals, EnCase, they put it perfectly. They said linking a file to a SID is basically the same as finding a piece of trash in the real world with someone's name and social security number stamped all over it. It's that direct of a link.
So, the next time you go to hit delete, just remember, your computer is a silent, incredibly meticulous witness to everything you do. It remembers it all. The only real question left is, what story is your digital footprint telling?